Hello guys and welcome to this another video, and guys, in today's video we're going to be talking about the reticular formation. Very important, a part of our brain stem. So it's going to be located in our brain stem, and it has six main functions. So these six main functions are going to be here. It looks very complicated, but please do not feel scared. Very simple, and I'm going to be dropping a mnemonic on the next slide. So let's get into it.
It helps to modulate the heart rate. Second one is going to be respiratory rate. It also helps to maintain the respiratory rate. The third one is going to be the main one. This is going to be really the vital one, which is posture. It helps to maintain the posture. I'm going to speak about loads of this in the upcoming parts of this video. The fourth one is going to be state of consciousness. So the state of consciousness basically means that whether you're in a coma or whether you are awake or you're asleep. So when you're sleeping, it's because your reticular formation is not activated. Habituation. What does habituation mean? Habituation basically means any sort of thing when the brain accepts a habit. So obviously but like for example, sound of the fan. As the fan is there, we don't think about it all the time. It becomes a habit. The next one is going to be pain modulation. What does any of this one mean? It means to modulate pain, or the pain signals that are coming from the lower part of the body reach the cerebral cortex, and this is going to be the origination of the descending analgesic pathway. Here's going to be a really bomb mnemonic, and this mnemonic is going to be very good and very vital for remembering all the functions. Yes, you heard me right, all the functions. This next slide over here, it may look complicated, and you may think I'm going to quit medicine because how complicated this slide is, but don't worry, guys, this slide is very simple. What is reticular formation? Reticular formation is going to be multi-synaptic connections that connects the core of the brainstem cortex, and is being reticulated in appearance in myelin material. So you may be wondering, what does reticulated mean? Reticulated kind of means like if there are many wires together, so we call them like kind of like a reticular formation. So there are many, like if they're together, kind of many wires are together. The next thing is going to be so also over here, what's going on over here. So obviously we have our big boy over here, the cerebral cortex, and we have the cerebellum here, and then you can imagine this is going to be the spinal cord. So we need a bit of imagination. But so what's going to be happening here? This is going to be the main man of the show today. It's going to be reticular formation. So I'll put that in kind of in a bright color, so we all remember this is in reticular formation. But this also over here is also a big boy. This is going to be the corticospinal tract. Corticospinal tract is basically there for controlling your voluntary muscle movements. So all my voluntary muscle movements I'm doing right now, as I'm making this video, as someone is playing football, as someone is playing basketball, someone is running, we're all making voluntary movements. That's controlling corticospinal tract. But there's going to be no connections with the reticular formation. So a voluntary movement is obviously going to be connected with reticular formation. Obviously, as I said, the reticular formation is there for posture, so there has to be connection with the voluntary movement. The next pathway that I really want to drill in your mind, again, the big boy over here is our reticular formation. This is going to be a part of our brainstem over here, and this is going to be our cerebellum, cerebral cortex. This area here is going to be brainstem. Yes, reticular spinal tract. Reticular spinal tract is again a descending tract, and is again going to be communicating with our reticular formation, and it's also going to be having obviously other types of connections along the way, which is one of the many sensory pathways. So one of the sensory pathways is going to be from the lower parts of the body all the way to the cerebral cortex, and there's going to be many sorts of connections through reticular formation. What is the reticular formation's relationship with the vestibular nucleus? Both the vestibular nucleus and the reticular formation, they provide information to the spinal cord about the posture of the environment and disturbances in body position and stability. Vestibular nucleus is going to be the nucleus that makes adjustments in the posture, the equilibrium in response to the information from the inner ear. So what does that mean? That basically there's going to be direct projections to the vestibular nucleus in the spinal cord to ensure rapid compensatory response to any sort of posture instability detected by the inner ear. Vestibular nucleus is going to be basically influencing two main things: posture and equilibrium. And there's going to be direct projections between the vestibular nucleus to the spinal cord, and that's going to cause rapid compensatory response to. So what does any of that mean? So basically we're going to be drawing a very nice brainstem over here, but it's not going to be very detailed. So just imagine this in the brainstem, and then on each side of the brainstem we have our let's just say a vestibular apparatus. Should draw them a bit smaller because obviously they're much smaller than the brainstem. So this is my vestibular apparatus, which is obviously in our ear. So we can imagine that's something in our ear. So once is going to be the vestibulum, and then going descending is going to be the vestibular spinal tract. So that's going to be really, really important here. That this is going to be connecting here. It's going to be connecting with the vestibular nucleus. The vestibular nucleus is going to be also over here. Vestibular nucleus is going to be connected, and obviously there's going to be a mirror image. Motor influence on reticular formation. Upper motor neurons of the reticular formation maintain posture, can be appreciated by analyzing activity during voluntary movements. And then the simplest movements are going to be accompanied by actions of the muscles at a first glance, and they're going to be seem to have little to do with primary purpose, and also simplest movements are going to be accompany the action of muscles that at a first glance seems to have little to do with the primary purpose. So upper motor neuron of the reticular formation can be appreciated by analyzing their activities during voluntary movements. The simplest movements are going to be accompanied by the actions of the muscles, which at first glance they have very little to do with the primary purpose. The reticular formation. The reticular formation has two types. Either can be ascending or descending. So either we're going to be talking about going up or down. So so basically the ascending and descending is going to be there all the time. And ascending reticular formation, there's going to be mainly two main parts. There's going to be a distal part, and there's going to be a proximal part. So the distal part is going to be there mainly for the distal part is going to be mainly there for the controlling of the reticular formation, whereas the proximal part is going to be there for the control of the consciousness and the gaze, whereas the distal part is going to be more there for the cardiovascular, and it's going to be more of there for the controlling the respiratory rate. There's also going to be other stores, so brainstem nucleus. So these brainstem nucleus are also very, very important, and there are three main brainstem nucleus. There's going to be I'm going to be, by the way, drawing all of this. So if we have like I said, there's going to be distal and proximal part. So what's going to be happening in both parts? So basically in the distal part is going to be there for the cardiovascular and respiratory rate movements done by the midbrain. Then the next one is going to be influence on the posture. So influence on the posture is going to be there. Influence on the posture is going to be there through the decebrate or decorticate. So they can be rubrospinal tracts. We can also have obviously vestibular. So I haven't drawn this pathway over here, but it can also be over here. And one second. The main thing that's going to be causing the influence on the posture, decebrate and decorticate. So decebrate is going to be there when we're going to have having the extension. So that can also be there. So when we have extension, so basically the brain is not allowing our brain is going to be not allowing the flexors to be working over here. So our brain stops an inhibitory signal towards the red nucleus. We can maybe get this type of disease. So what type of disease would this essentially be? So decelerate will essentially be exactly when we're going to be getting we're not able to flex. We're going to be extending. So we're going to be getting a lesion over here, whereas the decorticate is going to be when we're going to be getting a lesion in the red nucleus. So a lesion in the red nucleus would be something like lesion between the cortex and the red nucleus. So that's going to be there. So this lesion is going to be somewhere over here. Influence. So like I said, influence. It basically means you're all extended. So key point over here is extended, and decorticate basically means you're flex in the upper limb, and everything else is extended. So flex in the upper limb, and then everything else is going to be extended. So that's going to be really, really key working over here. Reticular formation influence on the movements. They can be some sort of somatic control of the movements. They can be also some sort of somatic control on the movements. So some motor neurons, they send the axons to the reticular formation, giving rise to reticular spinal tracts. and the functions of the tracts are balance, posture, maintain tone, especially during the body movements. Reticular formation also relays eye and ear signals to the cerebellum. So the cerebellum, so that it is integrate vestibular and visual and vestibular stimuli. The reticular formation helps to maintain posture, so that's going to be very key, and its influence on the anti-gravity muscles. So vestibular-spinal tract, and what is the influence on the anti-gravity muscles? So vestibular-spinal tract is going to be there, very important for the anti-gravity. When it comes on the anti-gravity muscles, then it's going to be having its influence to the vestibular. So I explained that in proper detail over here when I drew a diagram here, that this is the vestibular and it goes to vestibular nucleus and vice versa on the other side. But what I'm trying to say over here is that what are the key structures? So we have the maculae and the cristae. Cristae ampullaris is going to be a sensory organ. Credits to open assembly because I'm basically plagiarizing the picture. But essentially the key point is that there's a cristae ampullaris. It's a sensory organ. So as our head direction goes, the cristae ampullaris will go in the opposite way, and through the sensing nerves, it's going to be feeding into the vestibular nucleus, I believe so. And it's going to be really making an influence on our posture. So that's going to be really, really key. The medial nucleus, what I mean by any of this medial and lateral nucleus. So medial lateral nucleus, again, I have to be plagiarizing something, so draw it to know it about medical biology. Basically, there's a medial, there's a lateral, and there's an inferior and superior nucleus which is present in these brainstem, and that feeds into the spinal cord. So what does a medial nucleus do, or aka what does this nucleus do? The medial nucleus, what happens is that it has head and neck maintain head tone, and the lateral muscle is going to be there for muscle tone. Axial and lateral movement is going to be there for fine and precise movements. So what does any of this mean? So the voluntary movements, I spoke about this, is going to be controlled by the corticospinal tract, and so the anterior corticospinal tract is going to be there more for axial, and the lateral one is going to be there for the fine and precise movements. So the same way, once our corticospinal tracts are going to be there, there's also going to be obviously an influence on our head and neck movements and axial and end extension muscles. So that's also going to be very, very key coming into this disease. What's going to be the function of the vestibular spinal tract? The vestibular spinal tract is going to be there for the anti-gravity muscles. So it starts obviously for vestibulum. I haven't drawn that here, but I can easily draw it over here. So I'll draw this is supracortex brainstem, this is supracortex cerebellum brainstem. Cerebellum is behind the brainstem, but I've just drawn this two for simplistic state. Ears, or two vestibulum over here, inner ears. They're going to be communicating with the sensory nerves through the to the vestibular apparatus, and once they're going to be over there, then it's going to be communicating with the vestibular nucleus. Vestibular nucleus sends there are two fibers down, medial and lateral fibers. We spoke about this medial and lateral, I showed you in the photo over here. So medial vestibular spinal tract and lateral vestibular spinal tract, and then they go to obviously two different muscles. So these medial we're going to go to which muscles? We spoke about this, head and neck. Very, very important to say that, head and neck. And the lateral one is going to be there for the lateral tract is going to be there for which type of movements? Is going to be there for the fine and the precise movements of the limbs. The next one is going to be the ponto-reticular. So this track over here we drew is going to be vestibular spinal tract. So I'll draw, I'm going to put that in a highlight. The next one is going to be the ponto-reticular spinal tract, and also please, it's an extensor tract. It's extensor muscles. This one, same thing, extensor muscles. So they both have very similar muscles functions. So ponto-reticular spinal tract is there's communications with the reticular formation, and these communication formation will allow it to extend muscles. So it's going to be very similar to the vestibular spinal tract, and it's a sister. It's the main thing I would like to say. It's kind of like an assist. It's like and when we go here into the anterior horns, I haven't drawn in detail, but there's alpha and there's going to be a gamma. This is going to be for the contraction of extrafusal fiber, and gamma is going to be there for a contraction of the intrafusal muscle fiber. They can be ascending tracts will give collateral reticular formations, like the spinal thalamic tract, dorsal column meniscus give collateral reticular formation. There is no cortical information, so reticular spinal tract has nothing to do with our brain. Pathway we're going to be talking about is going to be called the rubrospinal tract. Notice over here, very important difference. It's a flexor muscle. Rubro also spinal tract is going to be assisting the corticospinal tract, which we spoke about, and there's going to be globoform, and I believe there's going to be connections with the globoform and embelliform nucleus of the cerebellum. So connections again over here with the big two nucleus over here on both sides. So both sides of the cerebellum, there's going to be connections connections. I haven't drawn those connections. I'm not too sure where the connections, but we can imagine that there will be connections with both nucleus to the to these source of to the sort of pathway. So that's going to be very important. And alpha is going to be for contraction, gamma is going to be for keeping the muscle tight, red nucleus is going to be getting information from the cerebellum, and there's going to be influence on the global form and embryoniform nucleus, because the red nucleus is going to assist for the lateral corticospinal tracts. Medullary reticular formation tract is going to be there for flexor muscle. They're going to stimulate the medullary reticular formation, and they're going to assist in the rubrospinal tract. So they're going to be influenced with the reticular formation, and they're also going to be assist in the rubrospinal tract HK. So guys, thank you so much for watching. Hope to see you guys next time. Please subscribe, like, and hope to see you guys next time.